Welcome everybody. This is a video about the general term of a linear pattern. I am your majestically bearded host, Mr. Shirley. Now, I would like you to please write down a note as we go through this. Again, you won't have to write down everything, but there will be a bunch of it in this particular note because unfortunately this is sometimes a bit of a trickier subject. So feel free to ask me lots of questions in our meetings or by email once you've gotten through this. Now, I would like you again to title and date. Oh, apparently I switched page and date just to mix it up. Wow, surprising. Okay, our learning goal, which you don't need to write down, is to consider how algebra can be used to represent patterns and make predictions. Now, before you run away screaming at the mention of the word algebra, just keep in mind that the algebra we're using is fairly straightforward. It's much the same way that you would use a formula to find an area of a shape, for example. Okay, so we're using a fairly simple formula. But it is algebra, and you need to get comfortable with the word, especially since I love algebra, so you are stuck with it at least until the end of grade 8. Lots and lots of it. Okay, on we go. Now, a little bit of terminology related to patterns. So t with a little n, it's called a subscript, but I will usually say t to the n or tn, is the term in a pattern that's in position n. Okay, so for example, t with a 1 down there just means whatever number is in the first term, or in the first position. Okay, t with a 2 is the second term in the pattern, and so on. Okay, so t with a 50 down there would be the 50th term of a pattern. It's just one way of telling someone reading it or making a question so you can pinpoint which term you want. Okay, and just a reminder that a linear pattern increases by adding or subtracting. You don't need to write that unless you really want to, but for this today we are only looking at increasing linear patterns. Okay, we're going to focus in on those just to help this get you familiar with what we're doing here. So again, increasing linear patterns just for this one today. Okay. So just an example to try out what was on the last slide. Take just a moment, pause the video, and try and answer these two questions. Okay, I'll assume you did that. They're fairly straightforward, but I'm still going to go over them because it's important that you grasp this so you don't get lost later on when I use the same terms. So remember, T3 is whatever term is in position 3, okay, which in this case is 12. Okay, so first position, second position, third position, yay. And this pattern is a linear pattern, in case you didn't gather that one, because we're adding just 4 each time. Okay, this use of terminology, sorry, I'm going to back up 1 second to the slide before, using the t with a number down underneath there, that can be used in any kind of pattern. It doesn't have to be linear or exponential or anything. It can be any pattern. It just tells you, it's just asking you which number is in that position. Okay. All right. Now, yes, you need to write all this down. This slide, there's lots to it, but I will explain it all on the next slide, and we'll put some numbers in, and that will help things be much more understandable. Okay. So a term in a linear pattern can be represented by this algebraic equation right there. It's beautiful, isn't it? Okay, so t to the n, which means the term that's in position n, is equal to a times, that's not an x, that's a multiplication, times n minus 1 in brackets plus t1, which is the first term in the pattern. Okay, so the a just represents the amount it's increasing or decreasing. Okay, n just means the term number, and again, t1 is the first term in the pattern. Okay, so I've written it out like that the one way, but on the bottom, please note that I'll often write it like this, like you see here. Okay, which is exactly the same thing, I just sometimes won't write the multiplying sign in between the a and the bracket. Okay, but if you remember back from when we did order of operations, if there isn't an operation in between two things like that, between a number and a bracket or something like that, it means that you are multiplying them. Okay, So let's do a few examples, and that will make this much clearer. Okay, so to start off with, we're finding the general term of this pattern. Okay, and you know what, I'll come back to what I was just about to say. So first thing, what I've got in the box over here is just a reminder of the formula for the general term of a pattern. Okay, this is just right from the last slide. Now, remember, A is how much it's going up by. Okay, so hopefully you notice that it's going up by 3, so the A is 3. And the first term, that's T1, is 2, because that's just the first term. Okay, so then what we do is we substitute in some of the numbers to make a little equation for that. Okay, so Tn, so the term that's in position n, I know, algebra, yay! And then we put, remember, using the formula over here, so we put the 3 in where the A used to be, and we put the 2 in where the T1 used to be to make a new formula. Okay, so this formula right here is unique to this particular pattern right up here. Okay, so every pattern will have a unique general term. Now, there's sometimes slightly different ways you could write this. There's algebra you would use in future years of math where you could simplify this a little bit and make it a little shorter, but it would still be the same numbers. Okay, all right, now we get to the real reason why this is helpful. Okay, and why this is a handy-dandy thing to be able to do. So if we use the general term, which is right there, to find the value of the 10th term in the pattern. Okay, so rather than writing out 10 terms, which, yes, I admit in this particular example would not really be that difficult, but please bear with me as we go through the method. So the first part here is just our formula from right here. Okay, we just took it and moved it down. Maybe I'll do some pen drawing because I haven't done that in a while. So this is just the formula right there. We just took it from right there. And then what we need to do is we need to use that formula that we made for the 10th term. Okay, so what we do with that is we take the spot where the n used to be and we put a 10 in there because we're looking for the 10th position. We want a 10 in place of n. And because that rhymes, you know it's very important. Okay, and then you just need to do some order of operations with that. Okay, so remember, brackets first, then multiplying, then adding. Okay, so brackets first, so 10 minus 1 is 9. Shocker. And then 3 times 9 is 27, plus 2 is 29. So that means the 10th term, if we were to write them all out, would be 29. Okay, now, even more handier if we wanted to find the 100th term. And yes, surprisingly, this does happen in real life all the time, except most people would use calculators or computers to figure this out. But this is a thing that regularly does happen. So to find the 100th term, we do the same thing as before, except instead of a 10 in that n spot right here in our equation, we put the number 100. Okay? And then you just use order of operations again. So 100 minus 1 first, then 3 times that, and then add 2. So you're left with 299. So if you were to write out 100 terms of this pattern up here, you would get the 100th number in that series would be 299. Okay, on we go. We're just going to, you know what? I'd like you to pause the video, try out this example. Okay, excuse me. I'll assume that worked out. You did that well. I'll go through this one fairly quickly to try and keep the video slightly shorter than it might be otherwise. So, patterns going up by 9, and the first term is 1. Okay, that means your general formula should look like that, with a 9 in the spot where A used to be, and a 1 in the spot where T1 used to be. Okay, then we use our general term to find the 30th term, or the value of the 30th term. So the 30 would go in place of where the n used to be in our formula that we've made. Okay, that's all a general term really means. It's like a formula that you can use to find the value of anything in that pattern. Okay, that's all it is. Okay, general term is just a more algebraic way of saying it, and the way it will be used in the future, so I want to make sure you're comfortable with it. Okay, so our answer would be 88. Okay, now, one last slide, and yes, I want you to keep writing down some of these examples. The other way that you can use these is I could give you a general term of the pattern or a formula for the pattern, which is what is right here, and ask you to find some of the terms in it. So I'm asking you to find the first 5 terms of the sequence. Okay, now this is a little repetitive, but you'll be able to speed it up just a little bit. So the first one, remember you're just putting a 1 in place of the n because you want the first term. Okay, and then if you do the order of operations there, you'd end up with the first term being 2. Okay, then you repeat the process, again using our formula up here. So because we want t2, we would put the 2 in place of the n, order of operations again, and we'd end up with 7. Okay, same for 3, and you'd end up with 12. Now, if you notice here, we're going up by 5 each time. Okay, it's also that 5 right there. You can maybe start to shortcut some of the math. Once you're certain what it's going up by on a question like this, please feel free to just keep counting up instead of always going back and doing the order of operations. Okay, I did it for these last 2, but hopefully if you were going through and you were just sort of figuring out what the next one would be just by doing some counting, that you ended up with these 2 as well. Okay, so it's just going up by 5 each time. So the first 5 terms are 2, 7, 12, 17, and 22. Okay. Oh, that's surprising. I guess that's the end of our slideshow. I'm as surprised as you are. Okay. Please try out the work that I included with this. And again, since this can be a little bit tricky, please feel free to ask me if you run into trouble in office hours or in the meeting. Thank you very much for watching, and have a super day.